Well, it looks like we can begin. Welcome back, everyone. So, first day of class for a class like this is usually kind of a weird experience. We talk for like 45 minutes straight about the syllabus, Canvas, page, how the course is going to operate. We did do a good amount of statistics starting out in chapter one, and we're now currently on example three. I think we're pretty much on target to finish the notes today, but I'm never going to try to rush through the material. That doesn't always feel satisfactory. This is important content, in my opinion, and so we'll go at a reasonable pace, never trying to rush the clock. Today, we're going to start off by going into example three, which is going to begin using RStudio directly. So I guess probably the biggest question I have is, how are folks doing on getting R and RStudio installed on your machines? Any kind of roadblocks, hiccups, or questions about that? Okay, well, if any R issues do come up, don't ever hesitate to ask. I'll be very happy to help out with that kind of stuff. And, well, let's begin then. We're in example three. So here's where we left off. We just finished off example two. Quick refresher was example two is more than anything just about the different kind of data types that we're going to be handling in class. Quantitative variables versus categorical variables, where a good way to spot the difference between the two is if it's a true quantitative variable, more likely than not, there's some kind of unit involved. It could be time, length, distance. Length and distance is about the same, but you get the understanding. And taking an average of that variable would make sense. For a categorical variable, the easiest way to spot it is maybe it's just a sequence of yeses and nos, or maybe blood types, or something like zip codes where it wouldn't make sense to average a set of zip codes whatsoever. If the whole purpose of the variable is just to categorize people, then the variable itself is considered to be categorical, or we could call it qualitative. So we went through a data set here that we're going to take a stronger look into over this chapter and the next. The first three variables turns out to be quantitative, whereas the last two are categorical. We're just classifying the individuals in this data set according to zeros or ones, where the definition is in this key. Well, we also wrote out through the instructions what the variables were. For categorical variable, we wrote out the actual classification categories as well. And that's about where we ended class. Any questions at all, folks, about getting through that problem there? Okay, well, let's get into the interesting part of all this. We're looking at mixed variables here. The course is going to start off by just looking into one variable type at a time, and then we'll start looking into bigger studies like this, statistical methods that mix quantitative and categorical variables together. But the next thing we should take a look into is how would we handle dealing with just one categorical variable on its own? And the next problem we'll look into just one quantitative variable all on its own. I'll often say things along the lines of the distribution of a variable, which is kind of a technical sounding word, but all we mean by a distribution is saying what are the particular outcomes, how many times do those outcomes actually occur, and that gives us a distribution. So down here, we have a distribution. There's a variable of interest, there's categories labeled, and we have the amount of occurrences that those categories occurred. So we could call this the distribution of the variable of interest. So here's our distribution. And to further look into this problem, it is a made-up problem, I have to be honest. And you can usually tell the problem is just totally made up if there is no citation. They're not always my favorite problems, but sometimes they're pretty decent ones just all on their own, where it's emphasizing more how do the nuts and bolts, maybe of RStudio, for example, actually works. But it's a pretty realistic looking one. It says epidemiologists are investigating whether there's a relationship between time of year and the diagnosis of Lyme disease in the Intermountain West, and that includes us. Researchers analyze records of 1,361 patients. So as we're reading through that, we might jot on the margin or just make a mental note. That means the sample size is 1,361. These patients are diagnosed with Lyme disease, and this is a study that occurred over a 5-year period. So maybe you could say it occurred from 2020 to 2025. And the study was done to see if the incidence of the disease is evenly distributed across the seasons. And probably it isn't, right? We could assume that bugs like the ticks involved with Lyme disease are more active in certain seasons, and the data now seems to confirm that. But before even getting that data at all, this is not exactly what the researchers would be looking at. They would be looking at this. Imagine this is your study. Maybe you're doing it for a biology class. Maybe it's for a master's degree, a capstone project, or a thesis. As you went to get the sample size of 1361 patients, your data is actually going to look like this. I'll open up example 3, and whenever you see me opening up a file here from the thumb drive, they're all completely mirrored and duplicated down here on the Canvas page. So I try to put in all the materials that we're going to be accessing for a particular chapter indented this way, so you'll know what we're about to pull up. It's usually just easier for me to pull it through the thumb drive than fussing with Canvas most of the time. So here's what your data would look like. New version of Notepad is available. Let me see if I can just click that away. Let me see if I can zoom in as well. Case ID, that's just a way to protect, say, patient privacy. It goes from 1 all the way down to, oh, sorry, I didn't need to scroll like that. All the way down to, well, there's thousands of observations inside here, right? So it just keeps on scrolling and scrolling. As you did the study, you're going to contact these people individually, determine when they contacted the infection for Lyme disease, and there's the last observation. So if this is our data, we'd be pretty excited about it. But notice the raw data is not extremely helpful. Scrolling through this doesn't even really confirm necessarily, to my eyes visually at least, that most of the observations are necessarily in the warmer weather. I've seen a lot of summers maybe, but it's kind of vague and foggy. This is pretty overwhelming data to look into. But the reason to mention all this is the next problem we're going to look into this is going to be, what is the variable? And sometimes that's a very, very tricky question. The last problem was a little bit more straightforward because we had a data table just saying exactly what we're dealing with. But with the current distribution of our categorical variable, it makes things a little bit more vague. So let's put this back into the problem. Here's what the actual data looks like that we produced. But the raw data would have looked like this. So here's our actual raw data. The data has just been summarized into the distribution of the categorical variable right here. I shouldn't have said that. It's our job to determine if the variable is categorical or quantitative. But either way we look at it, well, maybe that I should take that back. Depending on the way you look at it, that can be a pretty confusing question. When you see this table, almost looks like there's 2 variables, right? And that would kind of make sense in a way based on what we did on this table. We said that there was 5 variables altogether because every column in this data table corresponds to a variable. Here, that's not the case. This is not the original data table. This is just the distribution. Of the variable. So sometimes with the wording of these problems, it might have said variables. Here it was more kind of like a hint, just saying there's one here, one variable to consider, not the 2 variables that we might think we have. So already this is kind of a tricky question, determining what the variables are. When we looked at the last problem, we were looking at a snippet of the raw data. And if we focus here, it gives us kind of idea of what the variables should be. Still, there's exactly one variable in this problem, either table we look at, the distribution, the summary of the variable, or the raw data here. Case ID, just because it falls into a column, does not mean it's a variable whatsoever. This is really just considered to be a so-called identifier. So case ID is an identifier. It's not a variable. The variable in this problem would just be season alone. So we can solve this problem by saying the variable is season. We need to describe whether it's going to be categorical or quantitative. And again, just because we see numbers doesn't mean there's any quantitative variable that occurs whatsoever. This is not the quantitative variable. The quantitative it's not a categorical variable. Sorry, getting my words mixed up. This one is not a quantitative variable. The variable here, season, is the categorical variable that we're studying in this particular problem. We'll say it is categorical. And the outcomes are, well, kind of obvious. If it's season, it should be the seasons. And that's exactly what we're seeing in the distribution here of the variable itself. The outcomes are winter, spring, summer, and fall. Well, that's what's going on for, I have this mislabeled. This was supposed to be a part A in the problem. Let's put in a quick edit there. Any questions at all, folks, thinking about the variable for this particular problem? Okay, so there's lots to think about when we first start breaking down these kinds of data sets. Oftentimes in a textbook, this is all you see, just the summary of a variable when it's categorical, describing the outcomes below and the number of times those outcomes did occur for every single category. But that does make determining what is the variable in the problem pretty vague. If you think in terms of, I'm the one in charge of the study, how would I collect the data? It would look something like this. It gives you a better idea of what is the actual true variable of the problem. Well, what we're going to do next is observe if this is your problem that you care deeply about. Maybe you're about to do a PhD thesis on this kind of data. We weren't too happy by just scrolling through all the rows of the raw data right here. That's not a great way to analyze this data whatsoever. So the very first step in the data analysis was really to write out this table right here, the distribution. And we can get a really good idea of just what's going on with that distribution from this table alone. I'm trying to fix this participants window. There we go. But if we could put some graphics to that, we'd be doing an even a better job. So that's our goal next. Let's produce some quick graphics to correspond to this categorical variable. I would say the nicest set of graphics to display these data would be just an ordinary bar plot. If you do something like a pie graph, I'm not too worried about that. But a bar plot will be easy to implement, and I think it does a really good job of conveying what really happened with this data. So here's where we'll turn to RStudio, show how to get some quick graphics to this kind of data. Any questions or comments at the moment? Okay, so let's jump back to RStudio. Again, when you're pulling this up, the icon you're going for is the one that looks like this. When you go to first install R, you can just delete that icon for your desktop. Don't delete the program though. RStudio is just a program that sits on top of R that's considered what people call an integrated development environment. Just makes using R itself a lot more straightforward and easy for us to navigate. So open this program right here. And it looks kind of involved at first when we're first taking a look at this. First thing we want to do when we open an R environment is definitely click on that button right here, which, hang on, new file, is that what I want? Yes, click on this button right here, and we want a new script, or just click on Control-Shift-N in a Windows machine. And this is where a lot of action actually happens when we're using the calculator R. Using a script right here is really nice because we can make quick edits, run the script multiple times with small changes to see the effect. And if we did all of our typing down here, there's going to be a lot of retyping that you would have to do each and every time. Now, tricky thing for me is to try to get all of my windows to fit just right so we can see everything. We're going to focus on this distribution of the categorical variable and start just typing in the data. I'll put in the counts first. So we just need a quick name for this. You could be very brief, call these things X and Y, but it's really pays off to be a little bit more descriptive. I'll call this just counts. I went for lowercase, so decide on the case you would like to use, lowercase or uppercase, and just remember that each time you initialize a variable. You can write counts equals. Before I get too far, I should ask the class, is this font big enough to see clearly through class, or how about in Zoom as well? Awesome, thanks for the indication there. If at any time this just looks a little too small, I do believe there's a way to bump up the font on this. So just let me know if anyone's ever having trouble seeing this clearly. I know it's kind of hard to see on the projector from my point of view. Yeah, that doesn't look too bad. So you can write counts equals. If you read a lot of our syntax, you might notice that people often write it this though, counts and a left arrow. So a bracket pointing to the left and a little dash. Either way you go, whether it's a left arrow or equal sign, the effect is the same. There's some small nuances where equality and left arrow could make a change or make a difference, but not really with what we're doing with R. I'll often write left arrow. We kind of read it as counts, gets, whatever we're about to type in here. We're going to type in all these numbers. And it's kind of tricky the way you do this for the very first time. You type a lowercase c. What that just stands for is combine. We're going to combine all of these counts into just one vector, essentially. Put in a parenthesis next. Notice another parenthesis auto closes for us, which is just a kind of helpful thing RStudio does. And we have to put in the data, now comma separated. 102, comma. I personally like putting in a space because it makes it easier for my eyes to see a mistake if I mistype something. But you don't have to put in a space. You could put in a lot of space. Any of the white space you put in here is just read and ignored by the program itself. So I'll go like this, 682, 162. So there it is. It's our first line of code that we've written in the entire class. To see if it actually worked, a quick shorthand is you could click the run with this is highlighted, or hit Control A and enter. So with Control hit and A, it highlights everything inside of here. With Control still held, press and enter, runs everything that's highlighted here. So that's a pretty fast shorthand that we'll use pretty often. And notice something happened in two spots. It puts down here on the console what we just executed, and something happened here in the so-called global environment on the very right. This is where all the variables that we define are going to end up. It says we have something called counts. It's numeric. It's of size 1 row by 4 columns. And here's the data that we imported. Well, any questions at the moment, folks? Okay, let me know if something weird comes up. And it's pretty surprising how subtle an error can occur here. So say if you're doing this as a homework assignment and it's just not working, either copy and paste into an email and directly ask me about it, or maybe take a picture with your cell phone, or just discuss it with me during office hours. And I'll be very happy to diagnose and help you see what's going on. And again, RStudio is meant to help. It's not meant to be something that is a critical hurdle for us to go over in this class. So if you're having any trouble with the syntax whatsoever, email me and I'll send you the correct syntax and try to discuss what might have gone wrong. So next thing we need to import by just typing it in directly is season. So I'll go season gets. So the left arrow is my way of saying it gets the output of lowercase c once more to combine. I'm going to type this in naturally the way I would expect things to work. It's going to be incorrect, and we'll see what the error looks like when we do make an error. And let me know what the correction is if you happen to spot it. So let's just do what seems natural. I'm going to go winter, spring, summer, fall. So those are all 4 outcomes. Hit Control A. With Control still held, hit Enter. And tells us that there is A problem, error, object winter not found. It tried to read this line, season. The left arrow wasn't the problem, C in the open parenthesis wasn't a problem. But when it got to winter, R has no clue what to do with that. It says winter isn't defined anywhere, so nothing actually ran. We just hit an error. Anyone happen to see what the problem is, what the fix should be? Yeah, go ahead. Okay. Yeah, absolutely. We're trying to pass in programming language a string into this new variable here. It's a totally different data type than the numerical values that we were putting in. And so just like you said, the fix is on everything we put in, just wrap it around quotation marks. Bella says, is it because we haven't given it an objective yet? So we need to correlate it with the numbers we typed in. In a certain sense, yeah, that's what it's saying down here below. If winter actually was defined somewhere in the environment, it would know what to do with this. But actually, we're going to associate winter with that count of 102 in a slightly different way. So you're on the right track, but really the big error here was the data type has to have quotations wrapped around it like that to be interpreted as non-numeric data. So let me just retype it and show you what it would look like. We'll go C parenthesis, hit quotation marks, and it'll open and close them. Winter, spring, summer, fall. Notice it converts it to green. So if my comma is in the wrong spot, that's going to be another weird error that's going to occur. So if I put the comma right here, suddenly it's not going to run. Everything seems broken. And if that's a mistake I made earnestly on my own, it's easy to make these kind of mistakes. It's practically invisible to me. These are really hard to spot and diagnose. That's why working with someone in class, sending me an email when these kind of things come up are really a great resource to try to find these errors and see what went wrong. So let me put the comma right here, hit Control A, with Control held, hit Enter, and it ran. We now have a new variable, season. These are CHR for character data, and it shows us a little bit of a snippet. If you make this a little bit wider, it'll show all the values inside this. It's of the exact same size. That makes sense because the table is in a one-to-one correspondence from the categories to the counts. All we need to do now is create the graphic, a bar plot. Any questions to this point so far? Okay, so if we're going for a bar plot, here's another nice feature about RStudio. It's easy to forget the function you're about to use, so just start typing it slowly. BAR, and already there's three good candidate functions. Barplots.default.test, that's bartlets.test rather. We just want bar plot, and you can use the up and down key to select the right function. To enter it, it's going to autocomplete, so that makes typing pretty fast in here. If you're typing out histogram, for example, then you can autocomplete and get this just put in really quickly. The bar plot, well, it's going to be based off the count, so we can put in counts to start. We're going to build this up more and more because we have to use the season variable as well. But let's see how this goes in stages as we build up our graphic. Our graphic is going to pop up right about here. So that's why I made this a little bit different sized. Hit Control A, Control Enter, and here's our bar plot. Not the best, right? But I mean, looks like about the right numbers. The numbers were 102, 415, 682, the maximum count, and then 162. So they look like they're the right relative proportional sizes. But we would never publish graphics like this, right? If you were subscribing to an expensive journal or you bought an expensive textbook and you saw that, that would probably be something that made you angry. This is not really conveying much. It's missing the outcomes of the categorical variable season, so we have to bake that into our graphic. So that's the next thing we'll do. But first, any weird errors or issues coming up just getting to this point? Okay, let's go a little bit further and include the actual seasonal data. This is the next part that's kind of random. The function we need inside the function called bar plot is names.arg. Notice it auto-completes with an equals. We're passing values to a new function inside of another function. Whenever we do that, we often never use the left arrow any longer. So if you used equality everywhere, that's probably the most straightforward way to use RStudio, because here we must use equality. Hit enter there. It needs a variable. We have two defined, so we'll pass to it season. Okay, so now let's rerun this entire syntax. The mantra becomes Control A, Control Enter, and that looks a lot better. So there's two things we need when we're going to be producing graphics like this. We need something that tells us what is going on the horizontal axis. So that's what we have. The categories of the variables now printed, so that tape does a job. We also need to say something about the vertical axis as well. Both axes have to have some kind of description, but it's getting there. There's a little bit more we need to do. Another thing that's kind of weird here is, notice the scale just doesn't feel convenient. It doesn't put a number here, and the height of that scale is below the height of the largest bar in the bar plot. Feels like RStudio could have done better by default, but if we feel like that's an issue, we can change that as well if we'd like. But let's go in steps. First, we need a description for the y-axis. I'm running out of horizontal space here, so another thing you can do is just hit enter and just keep on typing on a new line. When this syntax is going to be read, it just goes left to right. When it hits white space because of a page break, it just loops around and keeps on reading whatever we're typing. Just make sure your closed parenthesis comes down along with it. So we want something here for the y-axis label, so we, without even knowing RStudio, might guess the function. Y label, and ylab comes up. It tells us a label for the y-axis. Sometimes typing slowly in RStudio is a good strategy just to see what all functions might come up. That's exactly what we need, a label for the y-axis. So hit enter to auto-complete it. And we could say a lot of different things. Go with whatever makes sense to you. If you set counts, that's all right. That's how the data was presented. You might say occurrences. You might say number of occurrences of a Lyme disease infection over the last 5 years, but that might start to get a little too long. It's okay to make it a little bit brief because the overall context is also here in the problem. I would probably just say ylab equals occurrences. But if you try to run this syntax, that's a problem as well. It's the same issue that we had here with the character data. You can't just say equals a value like this whenever it's non-numeric. So we need to put quotes around this one as well. Now that should do the job for us. Let's see if I made any weird errors in this. Hit Control A, Control Enter, and we have occurrences. If you misspell something, I'm not too worried about that. It looks like it's spelled right. Graphic doesn't look too bad. You can kind of stretch this around to rescale things as you see fit. But probably the better way to rescale things is click on the export function here, do the copy to clipboard operation, and it pops out the graphic. You can use this little control thing right here where the triangle of dots are, I don't know what to call that, to start to resize things, make it look however you think is appropriate. Try to avoid something like this, because now I've collapsed the graphics so much, I lost some categories. Try not to do anything like this either. I didn't even print it out. It was margins too large means the area I gave it was too small. But that's not going to be helpful either. So try to find a neutral middle ground. So I'll go for about like that. So if we were satisfied with this, this might be what we import back into our assignment. But because it's lecture notes, we'll put it into our lecture notes. But you might still be dissatisfied about this. This goes to 600, yet the data goes to a count of 682, near 700. So if this bothers you, you're not alone. I think that would bother me as well. That's something we can fix next. If you did include this as your homework assignment graphic, I'm not going to be super nitpicky about this kind of stuff. You can actually put in a ton of energy, completely customizing your graphics, doing all sorts of things. But we're not going to try to get too carried away, going on tangents for producing the graphics. But a decent tangent is fixing the limits on the y-axis. So let's make that our next change. Any questions so far with the syntax we wrote at the moment?
Hello.
Hello, any questions at the moment?
Yes, I was wondering how you got to like changing the shape of the graphic. Like what button did you click for that?
Oh yeah, absolutely. So that was this export button right here. So click on that export, and what you want is copy to clipboard option just down below right here. So
Thank you.
once you click on that, this pops out. Yeah, you bet. Other questions so far? Okay, so let's fix the limits on this y-axis as our next step, and then we'll be done with producing the graphics on this one. We'll just have to import it back into the notes. So next option, if you're changing the scale on the y-axis, it turns out the function is y limits, or y lim is the actual function, not y limits, y lim. So this says limits for the y-axis. That sounds pretty much what we want. And we want to give two numbers. We want to go from 0 to, let's say, 700 seems natural because it's a natural break, I'd say. If you put 682, for some reason in my head, that seems kind of weird, but I'm not going to be super picky once again. If the graphic has all the right informations, all the right labels, everything can be discerned, then that's going to always be good enough for me. But I'd probably go from this. I want to go from 0 to 100, but notice what I typed. Excuse me, 0 to 700, because I'm giving two numbers from y limit. I have to use lowercase c there to combine those two numbers. So from 0 to 700, that means two parentheses have to close. And the shading that RStudio produces is really important. See where the cursor is flashing right now? We have a shaded closing delimiter with a shaded opening one. If I go right arrow one more time, the final delimiter is shaded, that closing parenthesis, and the very first one is shaded as well. It tells you where your parentheses actually correspond. And it's easy to make a mistake just with these parentheses on their own. This is a massive quality of life improvement when it comes to writing out this kind of syntax. So hit Control A, Control Enter, and that's not too bad. 700 is just slightly higher than the maximum value. And this is the graphic that we would possibly import. The next step is, if you're doing this as a homework assignment, how do you get the graphic into your report? Well, it also depends on how are you doing the homework assignment. You're allowed to do your assignments just like I am. You might not be using a digital pen. You might just be typing everything out. That'd be totally fine. If you're the kind of person that would rather just freehand write out your assignment, that's okay as well. And if that's the case, just email me these graphics that are being produced when you send in the assignment. So let's see how this works. To get this into our actual report, click Export again, copy to clipboard again, resize it however you feel was going to look about right, and then click Copy Plot. See if this works. Go back to the report, create an appropriate display of these data. Didn't work. Let me try again. Hit Control V and something happened. My cursor is moving around. Let me see if I can recall how to make this work. Let's go from bitmap to metafile. Copy plot. And there it is. So I guess I'm getting a little bit rusty on RStudio. It's been a little while. Let's recap on that. So the way I'm going to copy this plot is export, copy to clipboard, needs to be as a meta file, and copy plot. Then come back here, hit Control V or just right click and select the paste operation. And now we have our graphics in our report. Comes with a lot of white space. So if you are a little bit worried about printing out tons and tons of paper, you're welcome to resize these as well. And I have a really, really strong prescription. So if you can read it, I can probably read it too after it's printed out. I usually wouldn't do it like this on our class notes. That's really hard to read. I'd probably make it bigger. If you want to make it a little bit smaller as you go to print them out, that'll be just fine. The next thing we'll do anytime we use RStudio is take all of the stuff that we've typed out and just paste it down onto Word. I'll often box out the syntax as well in this kind of way, just to give kind of a paper trail in the notes. This is the syntax we used to produce that graphic above. So as you're going to do the homework assignment, you can just copy this code in, change what you need to change to match the problem you're working with, and that'd be a great way to use RStudio as a tool. Any questions or comments so far, folks, with our first graphical display? Okay, I want to show you how I usually do this. It is kind of tedious to go to export, copy to clipboard, make sure meta file is selected and click copy plot. That's a lot of steps. So usually the way I do this personally is the snipping tool. It's fantastic. The snipping tool on just about any machine is a great thing to use. You could go Windows snip, pull it up, create a new snip, and a bunch of stuff happens, bring in the image. But there's a massive shortcut that's been around in Windows for a while as well. Hit Windows, Shift, S simultaneously, and this happens to your screen. Now you can just snip directly without actually having to call up a whole separate program. I mean, it is using that program, but so built into Windows that you don't need to open it directly. So once again, this is different in other operating systems, but other operating systems will just have different methods of doing the same thing. The Windows key, Shift key, S key converts your screen into this. Click and drag to about here. And this is often just the fastest way to grab your graphic. And I like going that way because it also doesn't put in a ton of white space above and below. Notice everything just seems to kind of fit better now that we went that route. So very often, this is how I'll produce those graphics. So we went from raw data right over here, which is kind of unreadable. I guess you could kind of see summer and spring occurs a lot, but it's hard to say a lot by how much relative to the other categories. The distribution of the variable was making it a little bit more clear. These are the actual number of individuals that had 102 occurrences of Lyme disease during winter, and so on. But the graphics paint an even better picture. Some people just respond better to graphics like this. And if there were many, many categories, it'd be easier to visually process all of this just through the one graphic. Well, that's the experience so far handling the categorical data. Last thing we want to do in this problem is just say something about it. Describe what you see in this display using the context. Context means we're talking about individuals with Lyme disease, so that should probably be mentioned. There is one variable, which is categorical season, and we have counts for how many Lyme disease occurrences occurred across those seasons. So we have to mention those kinds of things when we say what the context is. And I didn't say what level of description you have to put down here. I just said describe it. So anything you say here that's true, mentions everything about the context, would be about right. If I needed, say, paragraphs, I might have to say write at least 3 or 5 sentences. But this one's pretty open-ended. I'll leave it up to the class. What would you say is the biggest thing you'd want to say if this was your data that you're about to analyze? It's kind of wide open, right? There's lots of stuff you could say. while we're thinking about it, here's pretty much what I would say for this kind of question. Describe what you see in the display. My eyes are probably going to immediately just go to the biggest thing there, the highest category. Summer occurs the most often. Spring's not too far behind. Winter and fall have very low occurrence rates, but it looks like winter, it's pretty weird that you might get Lyme disease contracted in that season. But then it ramps up strongly as the season progresses and then drops off very, very rapidly, extremely rapidly. You don't necessarily have to say all of those things, but probably what I would say right here now is most occurrences of Lyme disease in this region. What do we mean by this region? I mean, that is part of the context. It was the Intermountain West. So you might have typed that in as well, but sometimes you can be a little bit terse and just say this region to stand in for the Intermountain West. If it feels like you're just rewriting the whole entire problem verbatim, you can simplify it a little bit and summarize just like we did here by saying this region. Most occurrences of Lyme disease in this region happen in the spring and summer. Well, I'd say that'd be about right. We're not meant to write down a book when it comes to this. If there were different things we need in the response, it would have to be mentioned in the problem. And a lot of people might really say a lot of different kinds of things. Again, you might talk about how it ramps up kind of gradually, then falls off a cliff once fall occurs, and then a little bit more during winter. There's a lot of stuff you could say about here. Anything additional that folks would like to add that's kind of jumping out at you? Yeah, exactly. So we really don't have to say too much about this problem. One way to determine if we really said enough is go all the way back to the very start of the problem. I know it's tedious to reread these problems over and over again, but sometimes that's the experience with statistics. Sometimes there's things that we might have missed the first time we look at the problem. Said epidemiologists are investigating whether there's a relationship between year and diagnosis with Lyme disease in the Intermountain West. They analyzed 1361 patients diagnosed with the disease over a 5-year period to see if the incidence of disease is evenly distributed across the seasons. This idea kind of was replicated twice in the problem. It seems to be like the whole purpose of this study. Is it evenly distributed, or is there a relationship between season and the occurrences of Lyme disease? So this might be one additional thought you might want to come back to. This provides strong evidence that the occurrence of this disease is not evenly distributed among the seasons. If you left that out on this kind of problem, I wouldn't be too worried about that. But really, the major thing we're trying to do is just say everything that we see about this display in a quick statement or two. Be sure to use the context. We used the context when we mentioned the disease itself, that it happened in this particular region. The actual outcomes of the categorical variable are all mentioning the context as well. And I mean, we don't want to highlight everything in yellow. It starts to lose a meaning if we did that. The thing that could start to make us lose points on say a homework assignment or an exam problem is if we just said summer is the largest category. We have to say a little bit more about what the study is about, what's really going on. And then that pretty much finishes off the problem. So that was our quick tour of dealing with a categorical variable, just one single categorical variable. Any questions at all, folks, on getting through this problem here? Okay, well, again, when you go to do this as a homework assignment, you can refer back to the lecture notes here. We'll be saving these and dropping them back into Canvas, just overwriting this file as we go through the course. And if any problems occur working with RStudio, don't hesitate to write about it or drop into office hours. I'll be very happy to help. Like I mentioned, there's no secrets in RStudio. I'm not going to say, well, try this, try that. We'll try to work it out the problem together, and I'll share the syntax that resolves the issue. So let's try out the next concept next. We've already produced one kind of graphic, the bar plot. That was relative to whenever we're dealing with the categorical variable. And the other type of graphic that we're going to produce in this chapter will be the histogram. And this will be whenever we're dealing with a quantitative variable. So what do we mean by a histogram? Some people are pretty familiar with these. Other people might not be too sure what's being conveyed when we say that. But it's just a nice quick display for dealing with quantitative data. So here's what a generic histogram might look like for an example. We'll have an axis. On this axis, this will be the quantitative variable. So if we're measuring time, age, height, distance, that will be the variable that goes along the horizontal axis. And I drew a vertical bar going this way. That wasn't meant to be a y-axis. Let's say our quantitative variable has a lot of data in this region between 0 and 1. Some of the data falls in this region. Some of the data might be around here. And if we have now finally a y-axis going this way, this axis is going to be frequency, much like number of occurrences in our last graphic. And let's say here, this is 1, 2, 3, 4, 5. So this is what a generic histogram would look like. And all the histogram is really trying to convey is if we go between, say, one particular category, let's look at the biggest one, between 0 and 1. This means there are 5 observations between 0 and 1. So that's all the histogram is really trying to convey. Likewise, there would be 2 observations between 1 and 2, whatever the units might be in this particular problem. Maybe it's hours, years, and so on. And just 1 observation in the data set between 2 and 3. Also, just by looking at the histogram, we could say even more. There's 5 observations in this category, this range, 2 more here, 1 more here. So that means the sample size n would be equal to 8 observations. So we'll be taking a look into a lot of histograms in this course whenever we're looking into a quantitative variable. The major reason for being very concerned about histograms is it informs us on what statistical method we can actually use for the kind of data that we have. Our favorite kind of data turns out to be symmetrical data, but occasionally we have to deal with some messy data which is skewed in one direction or the other. If our sample size is large enough, we might be able to overcome the skew in the data and use the method we want. But we can only really have that discussion in our mind, picking the right method, by looking at the data and visualizing it. How pathological does it look, or how symmetric is it? Other things we'll do when we are looking into a histogram is look for any kind of pattern that we see. We're looking at an overall following to the right kind of pattern on these data. We had an observation clear over here, an outlier. We definitely want to mention that. We'll also look into the shape, center, and spread of the histogram. This is more things we're going to be doing in chapter 2. Shape we'll say a little bit more here. But for center, we'll be measuring statistics like the mean or potentially the median. For the spread, we might be looking into standard deviation or potentially the interquartile range. There's a lot of different statistics we can select. And the most appropriate statistic just depends on what does the data actually look like? What is its shape, in other words? So that's the next thing we want to discuss in examining the histogram. The shape is of very, very fundamental interest to us. Any questions so far, folks, about just the overall definition of the histogram so far? Okay, so for some really quick histograms, let's do one that's skewed right. It might look something about like this. Let's give a unit. Let's say this will be days, that, prototype, light bulb, lasts. Maybe we're looking into a new kind of LED technology, for example. I don't exactly know what the units might be. Maybe it goes from 0 to 100, 200 days, 300 days, and so on. If you ran this kind of experiment, you might see data that looks like this very often. It's kind of a survival time type data. How long are these light bulbs surviving? You might find that most survive for quite some time. I didn't put in a y-axis since we're mostly just analyzing the shape more than anything. And then maybe it starts to fall off very, very rapidly. So most of our light bulbs look like they're rated to last between 0 and 100 days, continuous running, we might be assuming. Some of them, just by a fluke in the way they were put together, could last a little bit longer. Maybe a few last between 200 and 300 days. Let's go from 400 to 500. Occasionally with survival type data, whether it's organisms or technology like we're looking into on this one, sometimes there are outliers, just a few individuals that last a little bit longer than all the rest. This would be skewed right data. It's skewed right because the data, or the tail of the data, trails off to the right or extends further off to the right, making this right skewed. So that's the meaning for the right skewed data. These portions right here are what's causing it to be right skewed. For left skewed data, it might look something like this. Let's put in lots of observations here. And it could be not necessarily just falling off a cliff like we did on the right skewed survival data. It might be kind of gradual, maybe something along these lines. Let's put in a major outlier here, maybe an observation from here to here. And one thing that's kind of weird about data and statistics is usually it's easier to come up with scenarios for data that's right skewed. But coming up with a scenario for a data that's left skewed, I think it takes a little bit more imagination. That's not really easy to come up with. Anyone happen to have a good scenario that might fit data that looks like this? Again, it's pretty challenging. I have one go-to example that I mention every time. It would look about like this. Let's go 0, 10, 20, 30, 40, 50. Oh boy, I'm trying to make these evenly spaced. So let's say this is 60 and just imagine I did it right. 70, 80, 90, 100. Let's put percents on them. And this could be, say, exam scores on my most terrifying subject, which is probably chemistry or physics. Let's go with physics on this one. On a physics exam. So exam scores become naturally left skewed because there's a upper bound, assuming that the exam is capped off at 100%, which just kind of makes sense to me. And this is kind of unusual. Maybe this was an easier exam. Most people got between 90 and 100%. Kind of falls off a little bit to the left. And maybe there's a no-show. This person is going to do a makeup. So this person had 0%, but that would be the outlier in the data for this particular situation. Well, that's left skewed versus right skewed. This one is going to be left skewed because the data is now trailing off to the left in this particular problem. Does that make sense to folks, the differences between left and right skewed at the moment? Okay, so these are the challenging sets of data. I'm not saying that if our data is right skewed, we can't analyze it. But what I am saying is we have to look at the sample size and see if the sample size is large enough to overcome the level of skew that we see in the data. We're going to use a really interesting theorem called the central limit theorem, which will help us inform if the sample size is large enough. But the data that everyone kind of almost celebrates over is symmetric data. If you're doing a really long-term study and you don't have any clue what the data is going to look like, you finally get your data, say the sample size is small, like 15 observations. That happens plenty of times in statistics because sometimes these studies are expensive. And with 15 observations, a lot can go really wrong. But the data comes out symmetric. People practically celebrate over that because it means we can use very straightforward statistical methods that have a lot of power and not have to worry about the non-parametric so-called methods if the data became too skewed. So the nice data is going to look like this. Let's call this highly symmetric. Highly symmetric data would have a shape about like this. We'll have one main peak. Let me try to draw a better actual rectangle. One main peak right here on the dead-on center. This is where you would find the average or the median, for example. Then the data starts to trail off in about the same kind of way from the left to the right. Notice it's not perfect. If your data is exactly 100% perfect, that's pretty weird, especially on a low sample size. Data is naturally just messy, and so there could be some skew to this, but more overwhelmingly, it has a symmetric shape. It's not going to be skewed like this one, nor this one. Let's put it in a couple more categories. Another rectangle going this way, shorter rectangle going this way. Seems to be falling off a little bit more to the left than to the right. And then maybe one more. The data can be kind of messy. It sort of has a more smaller trailing off side here. We can even put in another category. But this is what highly symmetric data would look like. You will know that there's some symmetry in the data if you can print it out, your histogram, put a dashed line across the main peak that we see here, where most observations aggregate, fold over the paper, and if the categories roughly land in about the same height, again, it doesn't have to be perfect, but if it's roughly the same height across the board, then you're looking at symmetric data. Because of this one category here, looks like it has a slight left skew, but these would be excellent data. We would call these highly symmetric, despite the very slight left skew that we see there. So that's our rough look at the different kinds of histograms so far. We'll be producing a histogram on these notes here, as well as the chapter 2 notes. And oftentimes it's a first step when we're analyzing quantitative data, giving a complete analysis. So putting this into practice, we're going to be returning to these data, the FEV measurements. Any questions or comments at the moment so far? Okay, just a recap on the data. FEV is a measure of lung strength, how much air you can blow after full inspiration. We have a data set of children. They go from pretty low age to teenagers. An FEV measurement was made on them. Also, their height was measured, as well as sex, where 0 corresponds to female, 1 corresponds to male. The other categorical variable is smoke, where 0 means they're in the non-smoking category and 1 means they're in the smoking category, which probably meant they either are actually smoking individuals or they're exposed into an environment with secondhand smoke. It's kind of an interesting data set, and we'll be looking at it quite a lot in this chapter and the next. The very first thing we want to do with it is, let's produce a graphic. We're going to produce a graphic of just this variable here, FEV. Really, it's just a first step in the exploratory data analysis for this pretty large data set with multiple variables. We could have done a histogram for age, for height as well. But going for just FEV, here's how we'll get it done. Let's go back to RStudio. we're pretty much done with everything that we've been working on here so far. So if you want to just clear out your environment in one quick step, click on this broom icon. If you click on that, I'm not sure if it's going to make any difference on including hidden objects or not, but I feel like, yeah, let's just delete the hidden objects. That seems like a decent default. Hit yes there, and the environment becomes empty. You don't necessarily have to do that, but occasionally there could be a conflict with what you stored there and what you're about to use in the next problem, so it's just a best practice. Here, let's wipe this out as well. Hit Control A and just delete to annihilate everything. And now this next step that we're about to take is one of the major reasons why RStudio is a pretty good idea for a class like this. Our underlying data is right here in this notepad file, FEV. But it's another pretty gigantic data set. There's no way we're typing in FEV line by line. That could take days because I'm assuredly going to make mistakes doing that. Instead, we're going to import this entire data set into RStudio right away. This is a chore with base R. You have to type in exactly where the file location is. And if you make any mistake on your file location, it won't import. But RStudio, it's done right here on this button, import the data set. One of the more critical buttons on this whole program, in my opinion. Click on import data set. And the very first option is the correct option. RStudio pretty much knows how this is most likely going to be used. We'll go from text base, so click on that. It's going to open up your file explorer. I have this file contained in a thumb drive. You'll want to download it from here, put it in an easy to fetch location, maybe just in the downloads folder will do the job. Let me go down to the thumb drive location, double click on that or just click it and hit open. And this window looks kind of scary in a way, but it's also scary because it needs to be resized a little bit better. Let me redo this. So just to recap, I had to make my R environment a little bit bigger so that that next window didn't get cut off a little bit. Click Import Dataset. First option is the one you want. Double click on your file. FEV for this problem. And everything on this window is actually correct as it stands. I'm going to share with you files where you never really have to do any changes here. And if anything does come up, I'll try to rebuild that file or just make a big deal out of it in class. It doesn't look right. But you know, it looks pretty good. If you see all the actual variable names in bold, you're in the right track. So don't change anything here, just hit import. Something new happens in this environment over here. It's just giving you a view of what you've imported so you can determine, does that look right or not? Oftentimes I just click that away. Here is where I'm usually looking a little bit more carefully. You should now see something that says data. We have a so-called data frame structure, FEV. If you click on that little play button, it shows you all the variables to the right of a $sign, which looks kind of weird. So we want a histogram of these data. If you don't know the function, that's okay. Again, just start typing slowly, histogram, and right at HIS, the function is identified as just hist, standing for histogram. So here's the information on it. You can just hit enter right here. And we want a histogram. This is tricky this time because we have 5 variables contained inside of a data frame. So if I go FEV, that's the name of the data frame we imported, and it feels natural, but this actually won't run. Let's try anyway, just to see what happens. Hit Control A, click over here, then hit Control A, Control Enter, and it says, well, we ran hist FEV, error, X must be numeric. X is referring to the thing we passed to the histogram function. FEV is not numeric. It's a data frame containing 5 different variables, 654 observations. We wanted just a histogram of the FEV variable. But there's hints right here where the red dot is. That $sign is kind of weird, but think of it as select. Type a $sign directly, and now you can select any one of those variables. We just want to scroll up to FEV, hit enter on that, and we're in business. This will give us the histogram. Categorical data is honestly a little bit more annoying. This one goes pretty fast for quantitative data. Hit Control A, Control Enter, and here's our histogram. Well, I like the y-axis. The y-axis is doing just fine. X-axis is a little bit wonky because the scale kind of stops at 1, but the data is to the left, so we could correct that if we want. If you left that error there, I wouldn't be too worried about it. But I have two more big complaints. Anytime this kind of stuff comes up, really not the fact that it said histogram, whenever this kind of stuff comes up, we do have to correct it. This looks like some kind of weird software gore when you see $FEV. If this ever got printed in, say, like a publication or into a textbook, again, we should all try to get a refund on that because no one's paying attention to the graphics any longer. We need to say exactly what this variable is. And as far as this goes, in my opinion, and it is just my opinion, you really don't need a main title. We know we're plotting a histogram. We know what histograms look like. We don't have to say histogram of FEV. So this is what I would do next on this problem. This is a personal choice next. This is the opinion part. If you want to affect the main title, you type in main equals, and you can give it any title you like that makes sense. Just don't include things like $sign. There shouldn't be any R syntax inside of your main title. For me, I just go like this. Your title has to be between quotes, and I put nothing in there. So now if I run this, Control A, Control Enter, I've effectively deleted the main title. So I'll let that be your judgment call. You can delete it if you like. If it makes sense to say something about what the graphic is, you can type it out here. But oftentimes you'll see me put in this line when I do a histogram, just deleting the main title. We need to fix this next. FEV $sign FEV doesn't really make sense. I mean, FEV is right. That's the right quantitative variable we're trying to measure, the lung strength, FEV. So we'll go like this. That was the main title. This is the x-axis label. So we affect that label by going x label, xlab for short, and just type in what makes the most sense. You might just say FEV. You go that route. That would be okay with me. That does the job. But you know, for a quantitative variable, it's sometimes best practice to say what the actual unit is. So let's go FEV in liters is what the problem told us the actual unit is being measured. So hit Control A, Control Enter again, and that's our next graphic. I'd say that does the job. Frequency is correct. This is telling us how many times individuals, say between 2 and about 2.5, FEV in liters of lung strength occurred. It's about 150 individuals in this data set. This again feels weird to have some data, not very much, but falling off the scale. I don't know why, but that really, really bugs me. I'm not going to be hyper picky like I mentioned before if you left that into a homework assignment. But if that bugs you as well, let's fix that at the same time. We fixed a y-axis scale already by typing in y-lim for y-limits. So logically, to fix this scale, we should type in x-lim for x-limits. And if this ever pops up, it tells you you're on the right track. That's the actual function we'll use. Type in lowercase c to combine. Let's go from 0 to 6. Hit Control A, Control Enter. And I went kind of far. There's now white space over here, but this does the job. I'm not going to be super, super picky. I'll just leave it like this. You could work extra hard by the minimum value for everyone in this data set, put in that minimum value for your lower bound. But if it looks like this, again, that's all right with me. Then the next challenge is we have to import this into the assignment. So hit Windows Shift F for the snipping tool as one way to go. Highlight and just grab what you want. Go back to let's imagine it's a homework assignment and just hit Control V to paste it in. Then just resize as you would like. Again, that's just one way to do it with the snipping tool. If you like to go the other route, just as a refresher, here's what it looks like. Let's delete this. Another way to get that same graphic inside is click on the export key, copy to clipboard. Even if you're using a snipping tool, this is a great function because it allows us to resize. We should never resize it like this. I mean, that's pretty extreme. We should never resize it about like this because it's kind of hiding the relative changes as we go from lower lung strength to higher FEV lung strength. We should make it the actual heights just be a little bit more apparent. Other questions people might have is, should we change the width of those histograms? That's another thing you could control. But RStudio does a pretty good job of using different rules of thumbs, combining with the actual sample size of your data to find naturally correct widths to really emphasize how the data shape is taking place. So you really never have to control the width there. Make sure metafile is selected, hit copy plot, and Control V will place in that same exact graphic. Let's just kind of shrink it down to control that size. And we did it, folks. That's our histogram. Any questions whatsoever on producing that graphic there? Okay, I almost forgot personally to include this part. So if you ever notice I'm about to forget the syntax, don't hesitate to just say, hey, Mike, could you put the hit syntax into the document? And that would be very appreciated. If I just totally forget and class goes by and you come to the notes and you know syntax is missing, just send me a quick email. I'll correct that right away because my goal is to always leave a paper trail so you can use this as a tool. Just change whatever you have to change right here to match your data, your file name, and so on. So there's our histogram. Part B says to comment on the shape, center, and spread of the distribution using the context. Starting out with shape, probably the most natural thing to say is it symmetric or skewed? What would you all say about these data? Do you feel symmetry here, or are you feeling a skew in these data? Yeah, I would agree with you. Yeah, the right skew definitely, because there is an apparent trailing off of data here. So there's lots of ways to write this. It's not skewed like, oh, hang on. It's not skewed like these were. These were pretty, very blatantly skewed, right? So you might say something along the lines of, this is slightly skewed to the left, to the right, since it's trailing off to the right. I forgot right and left for a moment there. Must be getting tired. So you mentioned the shape. As far as the center goes, chapter one's kind of awkward. We would measure the center either using the sample mean or the sample median, but we just haven't gotten there. We're just going to eyeball it in chapter one, which feels kind of uncomfortable. If you compute the actual statistical value, that's totally fine with me. But this is what it's meant to be as an experience in chapter one. Center is where all the data seems to be aggregating, or piling up on is a better word, which is about here, or maybe between, say, 2 and 3 is about where most of the observations seem to be. So the central value, we're just trying to give one number. We might say about 2.5 liters. The center is at approximately 2.5 liters for the FEV measurement. So that measures our center. And spread is even weirder when we're in chapter one. If we were in chapter two, we might compute the standard deviation or the interquartile range. There's another way to measure spread. You could go from the minimum value up to the maximum value, and that certainly says how spread out the data is, min to max. That's a really blunt measure though. So we're going to do a little bit better than that in chapter 2. But if you're doing this as a chapter 1 assignment, what I would say for spread is the spread, let's put this on another page. The spread ranges from, let's estimate that. We could calculate the minimum in RStudio, but we're not trying to throw in tons of syntax on the first day getting going with it. So it's meant to just be visually approximated. It ranges from 0.5 liters to 6 liters, approximately. Again, if this felt kind of uncomfortable to you, I agree. We're going to do a little bit better in the next chapter. That's kind of the purpose of doing it right here and now. We can describe the center better for sure. We can describe the spread better for sure as well. But any last questions whatsoever, folks, on getting through this problem here? Oh dear, I just noticed we went a minute over. Sorry about that. I think I just kind of got excited about the problem. I'm going to try to always end right on time, 2:15. Sorry about going over today. We'll riff on the time next class maybe. But since we finished off chapter 1, that means assignment 1 is considered fully and officially assigned. The due date is going to be a week away from today. So that'll give you some time to get started, ask questions. You can bring questions to class, office hours, or email. And other thing I want to mention, sorry for rapidly doing the announcements after time. We won't have class on Monday due to the Martin Luther King Jr. holiday. So we'll be back at it a week away from today in chapter 2. Well, have a great weekend, folks. I'll see you all next week. Sorry again for going over. I'll try to make sure I'm paying better attention to the clock. I mean, I know some people, it doesn't matter as much, but other people have places to be. So sorry for shorting you on your time of the day. Have a great afternoon. And if any questions come up, please don't hesitate to write. Thanks.
The office hours right after.
Yep, pretty much it starts right now for us. Any questions at the moment?
No, not really. I just didn't want to get off yet.
Gotcha, I hear you. Yeah, you're welcome to just hang out. I'm pretty much not going anywhere right after class. I just kind of just clean things up, upload materials and so on.